everyone. Today we're going to talk about quadratic equations. Oh, quadratic equations, right? So how it could matter in our real life and how we can possibly use that. So as you may know, a quadratic equation is something like, let me start with a linear equation. Up to now we had something like x plus 3 equals 0, right? And well, everything is linear. Linear means the exponent here is 1, right? So what if we get it more, like we get like x power to 2, or the exponent is 2, plus 3x plus, I don't know, whatever, 10 is 0. And these numbers are just examples, right? The thing that I care here about is like these power here, the exponent, right? If that exponent is more than 1 and it's 2, this is called a quadratic equation. And normally in a linear equation here we have only one root. Here we have two roots. And how it could matter, it's like, pretend you're looking, you want to program a drone here. You want to program a drone to throw some package from here to here, where somebody is looking for it and needs that, right? If the drone is throwing that, it normally goes on a path like this. It doesn't go like on a straight path, right? It naturally goes on a curved path, and this curved path is most of the time a quadratic equation. Okay, so that's how we could possibly care to know the quadratic equation, because you might one day know how to throw this package and how to land it over here, right? Now in the next step, I'm going to show you a real example of quadratic equation and how we can find out the roots and the possible ways to get the roots out of that equation. Okay, now we're targeting quadratic equations, right? Let's get back to what we already were working with. It's like, for example, we like up to now we had x plus 3 equals 0, right? And then from here you would go, well, x is minus 3, right? Everything is linear. It's not quadratic because the exponent is 1, right? If we want to have a quadratic equation, we need something like x power to 2 plus, let's say 10x minus 20 equals 0, right? So these numbers, we don't care much about these. The only thing we care about that in quadratic equation is the power or the exponent of x. The maximum exponent should be 2. We have a 1 exponent here as well. It's okay. You can even have not this part. You could even have x power 2 plus 20 equals 0. You could have even x power 2 equals 0. Doesn't matter. The only thing is that you want to have a term that has a exponent of 2 for that variable, right? That's something we care about. In order to represent that, for the linear equations, whatever we had up to here, let's say on an xy coordinate, we had, for example, let's say 1, 2, 3, 1, 2, 3. Let's say we had a line, right? Let's say this line is x plus 3 equals 0, and this is 3. So basically, the root of the equation is where this line hits the x coordinate. So basically here, if I call it a has a coordinate of x and y, and it's called the root of that equation, because for that, sorry, this should be x minus 3 equals 0. For that equation, if you put x3 here, if you apply x3 here, this satisfies the equation, and it gets you a 0. So then if you plot that line, and if it hits x coordinate, that is called the root. And for linear equations, you only have one root, right? But on quadratic equations, on quadratic equations, your shape is not linear. It's like something like this. It's a curve. So now you have 2 points where the curve is hitting the x-axis, right? So now you have two roots. And there are some different ways to get the numbers of this root. For example, if it is x, I don't know, just as an example, 3 and x minus 2, right? In the next step, I'm going to show you how we can get these numbers from the equation, right? And remember, all these numbers are just for representations. The only thing we care in quadratic equation is this number here, which is the exponent of x. The maximum exponent should be 2 in that equation. Now, in the next step, I'm going to get into a real example where we are focusing on numbers, exactly numbers. So these are all just some representation. So right now I have an example. And the example is a quadratic equation, x2 plus 5x plus 6, 0. So what is the goal? What is the goal? Goal is to figure out x1 and x2. For example, just imagine x1 as like whatever, 3 and 10. And if I apply this 3 into this equation, it can get me 0. The same thing for 10, right? So these are called the root of the equation, right? So that 3 and 10 is just an example. I don't know what they are. My goal is to figure out and find x1 and x2, right? With the first look, it's not easy to get into the x1 and x2, but there is one way. It's called factoring. And factoring is telling me if I can convert this into something like this multiplied this equals 0, right? If I can have two terms, which is equivalent to this one, and if it equals 0, and if I, for example, let's call it a, b. If I have this term, I can tell either a is 0 or b is 0. Why? Because if I put a 0, whatever b could be, even 1,000, I can get to 0, because 0 by whatever is 0. On the other hand, if b is 0 and a is anything, like 2,000, again, it gets me to 0, because 0 to anything is 0, right? So then the goal is, if I can figure out an expression like this, and if I can find what are a and b, I can get to the roots of x1 and x2. And how we can do that? Basically, this thing here is called factoring, right? That method is called factoring because we have two terms multiplied, and this 0 helps us, right? So now the goal is what are a and b? Okay, there is a method called number pair. Number pair. And what is number pair? It's like, in my example, I had x2 plus 5x, the same example, plus 6 is 0, right? Let me just write it down as x2 plus bx plus c equals 0. Just b and c are some numbers, right? Anything. This is the general solution. If I can transfer this into something like now I need to have two numbers, right? And these two numbers are something, if they multiply, I get to get C. And if I add them, I get to b. What does it mean? Here, what are my b and c in the example? My b is 5. My c is 6. Now what I'm trying to say is, let's say I need to have two numbers. I need to have two numbers that if I multiply them, I get 6. And if I add them, I get 5. By some trial and error, you can get to 2 and 3. If you multiply 2 and 3, you get 6. If you add them, you get 5. So then these two are very important and the keys for me, right? Now I can transfer this into x plus 2, x plus 3. These are the same numbers that I found them, right? Basically, these two numbers are whatever that if you multiply them, you get to c. If you add them, you get to b. If you multiply them, you get to c. If you add them, you get to b. So now I know if I have a multiplied b is 0. If I have a multiplied b is 0, I can say a is 0 or b is 0. So a is 0 means x plus 2 is 0. b is 0 is x plus 3 is 0. So the roots are going to be x minus 2 and x minus 3. So these are the roots of the quadratic equation that we had. What did we do is, like, we have an example. I'll start over from here. We have an example. We have a problem. We have a quadratic equation, whatever you want to call it. And this is quadratic because the maximum exponent is 2, not 1. The maximum is 2. We have a 1 exponent, but we're caring about the maximum. So what is the goal? The goal is to transfer that into a way which we can have a multiply b is 0. And then from here, we get a is 0, b is 0, and then we find out the roots. But how we can get to this is the number pair method here. The number pair is telling me that you can write down the equation of, you can write down this as two number that if you multiply them, you get to c, and if you add them, you get to b. And then the goal is to figure out these numbers. Okay? Hopefully that made sense a little bit for you and made it easy, a little bit, maybe a couple of steps easier for you to understand the quadratic equations, how we call them quadratic, and how we can get to the roots or the answer of the quadratic equation. Now I have a question for you here. Okay, well, here. x2 minus 7x plus 12 is 0. My question is, what are going to be two numbers that if you multiply them is going to be 12, and if you sum them, it's going to be minus 7. I need to know what are these numbers. Can you comment them below here? And also, if you have any question, let me know down here. I try to get back to you as soon as possible. Have a good day.